Okay, we are gonna get started here. So, you guys enjoying PillarCon so far?
Yeah.
Yeah? Yeah? I know I am, and I know my kid is having a blast. He's likely tearing up the water park. I think that's probably his favorite part. He doesn't really go much for sessions. He's more, I mean, he's 2, so he's definitely more of a water park kid. But I did want to thank you all for coming to the presentation, because I've been working on this really hard. This topic in general, I mean, the computer vision stuff is neat, but the impetus behind it is really important to me. It's close to my heart. So I just really want to appreciate, I really want to call out that I appreciate the support of you guys being here. I have a lot of slides to go through. So normally I would just ask for, tons of questions and sort of have all of that interleaved with the presentation, but I have to move pretty quick. So I'm gonna kind of blast through that, and we'll save questions for the end. So what the plan is, just so we all have our expectations set, we will cover first the technical and creative journey that led me to that. We'll explain the problem statement that kicked off that journey. We will iterate through the solution together. We'll touch a bit on future work. We will have a short live demo. There will be time for questions, and there will be cake. So prerequisites, right? Some background to help get us oriented. First, I'm Alex Markley. Hi. This is basically just the stuff that you need to know. I like to make stuff. I'm a software engineer, music composer, and a writer, but the most important thing is that I really, really like to make comedy. I like to make comedy with my brothers and sisters. And from 2006 to 2010, we produced over 200 episodes of an audio dramedy podcast called the Malex Minute. It featured 3 main characters, Malex, Linus, and Snufflefungus, and they were improbable characters facing improbable situations and responding in improbable ways, as you might expect. And for some reason, improbably, we got a really good response to this show. Now, it was not we did not have a huge audience, but we had people from all over the world responding to this, and it was a good time. So here's the problem statement. First, we felt constrained by an audio-only format, and the main thing about that was that I just didn't feel like it was enough. I'm going to get into that a little bit more, but we actually got feedback from the audience that some members of our target audience just didn't feel like they could connect with the content and with the characters as much as they felt like they should. They liked the characters, they liked the premise, but the content, there was a disconnect. Because there was no visual, the theory was there was no visual for them to connect with. So the format was not engaging enough. And furthermore, the ultimate creative vision in my head and in the heads of the team overall was actually to produce a cartoon, right? We were writing it like it was a cartoon. We were thinking of it like it was a cartoon. And it wasn't just any type of cartoon. It was specifically a blend of live action and animation. So if you've ever seen Who Framed Roger Rabbit, that was the kind of thing that we were thinking of. And if you haven't seen it, here's a clip.
Better. I can't believe they locked me up for driving on a sidewalk.
Come on, Eddie, get in!
It was just a couple of miles. I'll drive.
But I want to drive.
No, I'll drive. I'm the can. Out of my way, pencil
So that's kind of the picture that we had in our head when we were writing this show. And there was some frustration that not all of that vision was coming across to the audience. So here's the problem statement. Ultimately, how do we bring an eclectic mix of characters to life on the screen in that way? Caveat, operating budget is roughly $0 per forever. No big deal, just small caveat. So there was a lot of early work on this. Again, if you remember the timeline, this show started off in 2006, and we'd been working on this entire time. Blender, if you're aware of it, is an open source 3D toolkit that can be used to do animation. It's also had kind of a rocky history and sort of a bad reputation as being incredibly daunting if you just look at it and you don't heave with like terror. It's very scary, and our first impressions were exactly that. It was just a terrifying experience, and we just dropped it right on the floor. We even looked at puppetry, right? We've all had some great fun watching the Muppets, and so we thought about that, but we ultimately decided that it would be a creative compromise and that it would be just too much effort and not really get us where we wanted to go. So, but ultimately, well, not ultimately, eventually in 2010, we did produce a demo using Apple Motion, and we mixed hand-animated 2D sprite with a 3D environment, and we came up with this. So that actually turned out really well, and we were pretty happy with the result. But unfortunately, it was basically all of the effort of 2D animation plus all of the effort of some 3D animation, and we just did not feel like it would be a sustainable model for moving forward with any kind of production. So finally, in 2013, Blender had matured. We confronted it, and we started getting some traction. Now, this was just a model demo, but Blender at the time did not have the ability to render toon lines to our specifications, so I designed an algorithm that would analyze the render and generate SVG output. So that was sort of the purpose of this render. But how do we get his fur to bounce? Because we didn't want a Monsters Incorporated sort of fur situation, because that didn't look like what we wanted. That would be too realistic. And animating his fur, the inertia of the fur manually with 2D animation was just a ridiculous amount of effort, and it required a high frame rate. We couldn't do a lot of frame skipping, which was just one of the reasons why it was such a high effort thing to produce 2D animation. So we tried Blender's physics engine, which produced some interesting results. We lost a lot of Snufflefungi. It was rough. But by 2014, we were actually getting results that looked pretty reasonable. And I was getting very happy with this. But what about facial animation? As it turned out, as I was iterating on these intensely technical problems and really focusing on getting the look that I wanted, I realized that I had kind of neglected effectively the hardest part of the entire equation. And I had lucked out because the character designs were basically really fuzzy Bob the Tomato. So there was no sort of articulating limbs to have to deal with. But still, even without limbs, facial animation is this incredibly hard problem. And as I studied sort of best practices in the industry, it turns out there's no way to approach it that's not obscenely manual, right? If you look at how Pixar does it today, they hire massive teams of people, and those people, there will be an entire team who is responsible for one character in the movie. And each character in the movie will have a team of people who are responsible for all of the keyframes for every single articulating bone in the face. That is the current industry best practice. And if you remember the problem statement, this has to be effectively free. Otherwise, the entire effort is doomed from the outset. Because I'm a full-time software engineer. I'm a husband. I'm a father of two. If there's any friction, then I'm not going to be able to get my creative vision out there. So as I really thought about this problem a lot, the gentle voice of inspiration kind of whispered to me and said, why don't you use performance capture, you dummy? And if you're not familiar, that's Gollum. He's a character from the movie, and they used performance capture on Andy Serkis's face. And so there's sort of two camps in Hollywood, right? There's the animation camp and there's the performance capture camp, and they sort of war with each other, right? And the performance capture camp is all about saving money and not having people develop horrible RSI diseases and retire when they're really young. And Weta Digital is in the performance capture camp. So I thought, well, what about existing solutions? Surely this is a solved problem by now, right? Yeah. So let's look at faceware technology. This was one that came up in my Google searching, and that guy, he looks happy, and that's an interesting screenshot. And if you look at this is another picture on their website that I got from their website, and they look really serious. There's a studio and everything, so it must be a very, very good solution. How much does it cost? That's the starting price. So I don't think that's going to qualify for us. So let's move on. What about another company? This is Dynamics YZ, and that's not pronounceable, so that's good. And this guy, he's really happy to be working on this software. So that's got to count for something. And from this screenshot, you can tell that when he opens his mouth, that character opens his mouth. So it must work, right? How much does it cost? Holy crap. That also does not qualify for our operating budget. So we're going to have to look somewhere else. Now, I'm going to take just a brief detour. And since I'm a little bitter that I can't afford any of these, they must be garbage anyway, right? And once you do get this output from this software, surely you have to tweak it, right? Because if you just pipe it directly into your video game, maybe you're not going to get the desired effect.
Sorry, my face is tired from dealing with everything.
You got to give her a break. Her face is tired. So what about in the Blender community? Is this done? Is there precedent for this? And it turns out, yes, there is precedent for this. Now, there's not a lot of detail out there. It's not a really well-supported workflow. There were a couple of showcase videos that kind of got me kickstarted. But basically, what it boils down to is you've got video that is of an actor, and you use Blender's internal interface for tracking markers on the face. It's just general marker tracking. And then you attach those markers to a special facial control rig, and then that controls shape key drivers that adjust the mesh. How hard can it be? So we gave this a try, and we came up with this.
Yeah, I know.
That one that we could possibly get of someone's face. It's
Right.
like- You know what time it is.
You know what I'm saying.
Time to spin the wheel of mythicality.
I did. There was a man there. He had a puppy. He asked if I wanted to come home with him and see all his other puppies. There was a man there.
Oh.
He had a puppy.
Oh.
He asked if I wanted to come home with him and see all his other puppies.
Oh no.
Of course I said yes.
Snufflefungus, you know better. Stranger danger is real. You have to be careful.
I was careful, and oh boy did he have so many cute puppies.
All right. Well, I guess it could have turned out worse. Next
He
time.
also had a dozen children locked in his basement, and he tried to lock me up too. What? So we had a battle. It was scary, but I won.
You won?
I defeated him and freed all the children. They each went home with a puppy.
So we were pretty happy with this, actually. It wasn't bad. There were a few things that we learned from this. I was not prepared for, one, tracking markers in Blender using Blender's interface was almost more time-consuming and labor-intensive than just animating the face in the first place. And furthermore, I don't think that it produced a better result. As much as I enjoyed doing this, and as happy as I was to see my character on the screen, I just don't think that that was a very high quality result. And so we challenged ourselves to do better. So as a software engineer, what do you think my first thought was? Write a program, right? So enter. Yeah, in Bash, right? No, I even better. C++. Right. So I thought, hey, this is a solved problem, right? Maybe if there's not a program out there that does it, surely there's a library out there that does most of it. And I was not wrong. This is a library called dlib that does markerless performance capture. Or markerless, facial landmark detection. It does a lot of other things also, but this is one of the things that it's renowned for. There were a couple of things, though, about it. This is a machine learning-based solution, and it can only recognize things that it has been trained to recognize. So when I started throwing clowning faces at it, and by clowning faces I mean something like this, it would blow up spectacularly. Spectacularly. Like the jaw would just go whoop, or the face would go. So in this project, I determined that for the most part, retraining would be out of scope because I did not want to train an algorithm for a program to detect my face. And I don't have the means to gather together a data set of hundreds of comedians in order to make this work better. So until I have the budget for that, again, remember our problem statement, retraining is going to be out of scope. So, I thought, let's just use markers, right? We want a practical solution, right? Let's just use markers. Let's go back to markers. So the first stage in this kind of pipeline has to be detecting faces, because if you're searching for markers, you need to be able to narrow the search space in the frame. And it turns out that OpenCV, another very important library, has models for this built in. They're called HAR cascades, and they actually worked pretty well to get me started. And a lot of these videos are from my video blog, because I was blogging my progress. So we'll kind of be showing clips from that. I didn't realize it at the time, but OpenCV's approach is not the state of the art, and the models are also not trained optimally. This will factor in later on in the presentation. We'll have to come back to this. So Detecting markers, also, OpenCV is spectacular at this. As long as you pay attention to a couple of fundamentals. Markers need to be prominent on the face. So we ended up choosing fluorescent paint, which you'll see in a bit. Also, when detecting markers, you have to choose the right color space, because with something like RGB, over there on the left, you're going to end up with a mess. But with a color space like HSV, you're going to have all of the colors. It's a cylindrical color space, and it's designed such that all of the like colors are in proximity to one another. So you get much better results. That's a Rubik's Cube. This article was really, really helpful in understanding the scope of the problem, and he's talking about how to programmatically detect what faces of the Rubik's Cube are showing. And here's another example with another face, and you can see the same problem. So now what? We've got, in detecting markers, we've got the marker colors separated, and their regions, there's bounding boxes around them. So I just have a list of an array. What now? It's just a sea of numbers. So I ended up choosing a domain-specific approach here, where basically if I know where the eyes are, because we went back to the eye model to detect the eye, I would figure, well, I've got two markers in here. Whichever ones are closest to the center, those ones must be the eyelids. And the top eyelid is usually above the bottom eyelid, so those ones must be the eyelids. And then sort of working outward from there, eyebrows and cheek and so on and so forth. This is fragile, but it actually worked. There's still improvements that I have to make here, but it turned out to work a lot better than I thought it would. So I didn't have to go crazy here. One caveat. In the initial implementation, this was highly serialized, so detecting any marker depended on the detections of all the markers before it. And so this will factor in once we talk about performance problems, because performance turned out to be a huge nightmare initially. Facial pose recovery. So when we're talking about the position of the markers on the screen, if I do this, that's not the same as if I do this, but the computer doesn't know that. And so I have to figure out what the pose is of the face, right? So the rotation and the translation of the face gives me enough information, at least this was my theory, to not bolt the camera to the actor's head, as you saw in the first demo, right? But also feed that information back into Blender and give us more to work with for the animation. This actually turned out to be the biggest problem that I had to deal with. This was the hardest thing. So let's talk. And by the way, I will not tell you about all of the things that I tried to do and totally failed, because some of the things that I tried to do to recover the facial pose are outright embarrassing. Just outright embarrassing. I will only tell you about the approach that was actually successful. And my excuse is that I'm running out of time. Let's talk about PNP solving. Let's assume first that you have a model where you can project points through a camera matrix. If you have 2D points on a projection, that you can project it through a camera matrix and get a ray in the scene. And that also you can do it the other way. So if you have a 3D point, you can figure out a ray through your projection through the camera matrix. If you have that, let's assume that you have a grouping of 2D points, and that those 2D points correspond to 3D points in the scene, and that those 3D points in the scene are pinned to vertices on a known 3D model. If all of those things are true, you have a solved pose. Now, the best part about this, OpenCV already implements all of the math that I just talked about. They have fully working implementations out of the box. So I had to do zero work. Except I had to meet the prerequisites. So how do we get a camera matrix? Turns out, you can fake it. You don't even need to build a camera matrix, because for certain applications, namely this one, it doesn't matter if there's camera distortion or any of those other problems, because you can just pretend that there's not. So turns out, just don't worry about it. All right, what about 2D points? Not going to get too deep into this because, again, lack of time, but I had thrown away DLib, brought DLib right back, because these points on the face that are more skeletal, they don't move when you change your facial expression. Those ones were stable even during clowning faces, and those ones are the ones that you need for your 3D model to recover your pose. Very quickly, I said that OpenCV's models for facial detection were sort of bogus and old school and not very ideal. This is where, in researching that problem and some of the other associated problems, I ended up using DLibs, because DLib has a more flexible interface, and it has, it actually has much more modern models there, including a deep neural network model that we could accelerate on the GPU. So what about a 3D model of a face? Where was I going to get that? Hey, Wikipedia to the rescue. If you just search for human head, you get this creepy diagram with really like obsessively detailed measurements. And as a result, I got a working facial pose recovery. And hey, that was really exciting. So moving right along, relative marker position. My first idea for this was, hey, if I'm going to get the relative marker position where I have the 2D marker on the screen and I need the 3D marker position relative to the face, I have to project it through the camera into the scene and then intersect with the actual face, making the actual expression. Otherwise, it's not going to be inaccurate. I started freaking out for a minute because I realized this isn't going to be possible. So I realized, calm down, what is the goal here? The goal here is cartoon animation. So actually, accuracy doesn't matter as much as quality. All I want is for the expressiveness of the actor to come through. So what if instead of intersecting with a face, we intersect with a plane? Right? Just cast a ray into the scene until we hit a plane that's aligned with the front of the face. It turned out to work pretty good. So on right here, you can see the marker positions recovered from the 2D positions on the left, and it actually worked. I'm going to speed through performance here. Initially, I had problems with performance. It was running on my desktop. It would run over 100 milliseconds per frame, which is really, really bad. I wanted it to be running at 60 frames a second. That means my hard budget is 16 milliseconds per frame. So not even in the ballpark. I spent some time multi-threading. That meant that, among other things, I had to break up that marker detection algorithm. I ended up finding a way to break it up into 4 quadrants. So, you know, the face breaking it up into quadrants. So I had multiple thread pools working on them individually, and that helped a lot. Pruning unnecessary work. I actually had more to say on this, but I had a bias initially toward optical marker tracking because that's what I started out doing in Blender. But it turned out that it was the most expensive part of the entire algorithm, and I was invoking it 20 times per frame. And I also figured out that it was giving me no benefit because when I turned it off, everything started working better. GPU acceleration kind of speaks for itself. I'm not going to tell you about all of the challenges I had getting it working. Just suffice to say, it was a pain. And ultimately, this was the result of all of those categories of effort. This number is in milliseconds per frame. I was very happy with that number. So future work, we ended up with, or things that I would like to do, user interface other than the command line since it doesn't count. Client server model for real-time data other than a pipe. Real Blender plugin aside from something that I coded in 2 days for this demo. Unit tests, please be kind to me. This solution was, the implementation of this solution would be analogous to a lost child wandering through the woods. Test driving was not really an option. So, but that's no excuse to not have tests, right? So I definitely want tests. I also want documentation. That's on the list, even though it's not on the list. Lip syncing, don't have time to talk about, but it is something that I want to do. If you're interested in hearing about lip syncing, please let me know, because it's going to be pretty cool. And last category of future work is, what are you interested in? This is going to be, it's open source under an MIT license. It's a GitHub project, and I'm interested in pull requests. I'm interested in issue reports. I'm interested in conversation. So, please join in. So, with that, it's demo time. How do you feel? Mic's on.
Testing, testing. 1, 2, 3.
All right.
Well, hi, Malex.
Hi, Snuffy. How are you feeling today?
I feel great.
Awesome. Are you ready for your live debut?
Yep.
All right, well.
Oh, hi, PillarCon. You must have some very interesting sessions going on about buildings and construction and pillars.
Oh, no. No, we're not architects like building buildings. We build software. We're software artisans.
Oh, I thought it was a conference about pillars.
Well, no. This is a conference that's put on by a company called Pillar Technology.
But what about the forge? Isn't that where you make the steel by putting it in fire and hitting it with hammers?
Well, no. The forge, we don't make steel in the forge. We make software in the forge.
You do have a crucible, though.
Well, yes, we do have a crucible, but it doesn't have any fire in it.
What about when the computer isn't working? Do you ever hit it with a hammer and throw it in the fire?
Not on company time, no.
So what do you actually do?
Well, most of the time, I sit in front of the keyboard and I type.
You should be called an IT worker.
Well, tragically, that does actually happen. So, there is that.
Okay, bye.
All right,
See you later.
bye. Everybody say bye. Bye, Snufflefungus. All right. Okay. He has done that before.
Do you have a marketing plan for the plushies to go with it?
We have sold plushies before. All right. So, questions?
So,
Yeah, thank you.
so what other solutions are out there? Is this, I mean, it sounds like you put this together at Zone and get anyone using it? I mean, what's the community response been like?
I would characterize this as the announcement to the community. So nothing yet. For the recording, the question was, what has the community response been so far? Come on, there's got to be questions.
It looks cool as heck, but I don't have a use yet.
What's that?
It looked cool as heck, and I don't have a use yet. But I want to.
Not having a use is fine. It's very, very niche.
Give us a little walkthrough. We can obviously see him, and we've got green dots. Is the light like a black light that's causing it to become more evident, or just give us a little walkthrough?
Yeah. So the question was, give us a brief step through the lighting setup and how the dots are working. So I glossed over this very briefly. The photographic prominence of the markers and how important that was. We initially started with neon paint, neon green paint, and that did not work very well at all because the exposure changes over the contour of the face. We could not get it illuminated evenly enough. So you're right, those are black lights, and those dots are fluorescing. So they're emitting their own light because they're excited.
A follow-up to that, I'm assuming this is your brother?
Yes, this is my brother Peter.
And you're the older brother?
I am the older brother.
You're missing a complete opportunity.
Yeah?
Real paint, no black light, and make him walk around all day.
Yeah. Well,
I'm the older brother, I thought the thing always
you know,
But don't actually tell him. You could have said, "Oh no, this is totally the black light."
Yeah.
Just let him walk around.
yeah, you know, I have experimented with sibling abuse a lot over the years, and I found that they're more compliant when you abuse them less. So.
Do you have any long-term applications for like motion capture for the full body, like in Who Framed Roger Rabbit, for the entire person walking around?
So the question was, what's the plan for full body applications? Yeah. So I have thought about it, and in the short term, it's not necessary for my production goals because both of my primary CGI characters are just heads. They don't have skeletal structures. Again, with the reference to VeggieTales, like they just chose to animate like the bare minimum to get something working. But there are actually better solutions out there in the wild for full body motion capture than there are for facial performance capture. So if you just do a search for open source or free motion capture, you'll find a ton of depth camera based tools like with the Kinect and so on, that for either free or a couple $100 you can use a Kinect and some software exporting to Blender a skeletal thing, and it might be kind of glitchy or whatever, but it's something. The thing that I could not find out there in the open source or free or just a couple $100 range was facial performance capture. We're pretty much at time. Is there maybe one more question?
How did you get started in this?
Define this.
What was your motivation behind the production?
We've always just really enjoyed creative expression and putting it out there.
How long have you been doing it?
Our whole lives.
I think the correct answer is already taken because it's there.
Yeah. Is that fair?
Fair enough.
Fair enough. Okay. I do apologize. It was a little bit of a bait and switch. I was afraid someone would walk out the door, so I had to keep you all engaged. And that's it. Thank you so much.